In this video we're going to learn about logs in the way that we would need them for scholarship calculus. We're going to learn the 5 main rules and we're going to prove 3 of them through the definition, and I'll leave the last 2 because they're very simple to you. We'll also look at an application of the scholarship log rules to differentiate a log to any base. The first thing we've got to do is be very familiar with the definition, and this is log to the base a of b equals c implies that a to the c equals b. We're going to use this time and again to prove our definitions, but we'll also use it while we're working things out in other questions as well. Now the 3 basic rules are that log a plus log b equals the log of ab, log a minus log b equals the log of a over b, and log of a to the n, this is the power rule, equals n log a, and this one's particularly useful. Now we're going to prove all 3 of these, and these last 2 I'm going to leave you to prove to yourself, which you can do directly from the definition, and of course this is true for any base, and you can try that one yourself. Okay, so first of all what we're going to do is we're going to prove that log a plus log b equals log ab. So we're going to put down a value for log a and log b. Then we're going to use the definition to find that a to the x equals a and a to the y equals b. We're going to multiply those 2 equations together, so we've got to add the exponents. We're now going to use the definition again, going backwards, for this one to write that log of log to the base a of ab equals x plus y. Of course we've got values for x plus y, and because we picked a arbitrarily, this works for any base, which proves our rule. Okay, we're now going to prove the power rule. So the first thing we do is say let x equal log to the base a of a to the m. So this is where we've got a power involved here, and then let so from the definition that gives us a to the x equals m to the m. But now let's do it without a power, so we're going to say let y equal log to the base a of m, and using the definition again we get a to the y equals m. Look, so if m equals a to the y, we can put this in there, and we get a to the x equals a to the y all to the n, which gives us that x equals ny, and we can replace x and y from over here, and that's going to give us log a of m to the n equals n, power brought to the bottom, of log a to the m. Okay, now let's use our third proof. I'm going to do this using the 2 previous rules that we've done. So all we're going to do here is change this minus to plus minus 1, and then we're going to bring this up as a power. We're now going to use the addition rule, so we get that's a times b to the minus 1, and just using rules of indices, there's the proof of that third rule. Okay, now let's see how we can change base. So the first thing we do is we're going to use the definition, and now what we're going to do is we're going to take logs of both sides to the base that we want, and I'm going to choose base t. Typically we're going to use base e for the natural log because that will tend to be more useful. We're now going to use the power rule to bring the x to the front. We're now going to divide by log of t of a, and then we've got x equals this, x equals this. So here we've changed it from log to base a to log to base t. I like to remember that this is higher than this, so this is the one on the top and this is the one on the bottom. Okay, so let's see a question in action. So I want to differentiate log to the base 10 of x, but we only know how to differentiate log to base e, or the natural log. So we're going to change the base, and we end up with this. Remember that log to the base 10 is a constant, whereas here x is a variable. So we end up with dy by the x equals 1 over x times 1 over log to the base e of 10. In the description below you can find a link to a worksheet that has questions that you can try on your own. I hope you found this video helpful. Staying in field with Winfield.